Good evening, sir. Myself Kirti, and I'm here to represent about the topic algebraic specifications. Introduction for the algebraic specification. Algebraic specification is a formal method used in a computer science for defining data types and their operation. The way we perform for different types of uh, it is depending upon the performance of the types, and it provides a mathematical framework for describing software systems and their behaviors, and this approach allows for clear and precise definitions, enabling rigorous reasoning about program correctness. And the algebraic specification has some formula, like that is an algebraic specified by giving a sort, means this is the same name of a set, and a set of signatures are present, and here it is with an example, and the properties are present over there. And key concepts in an algebraic specification: the primary component includes sorts and operations and equations that describe the relationships among them. And sorts represent data types, while operations define the functions that can be applied to these data types. Equations specify the properties and behavior that operations must satisfy within the specification. Algebraic specification components, and then that we have introduction, description, signature, axioms I guess, means the operation semantics by the defining axioms which characterize behavior. Syntax and semantics. The syntax of an algebraic specification defines its structure, including the symbols and rules for forming expressions. Semantics provides the meaning of these expressions, dealing how operations behave and interact. Understanding both syntax and semantics is crucial for effectively utilizing algebraic specifications in a software design. And here syntax gives the structure of statements in a language, and semantics give meaning to the structured symbols, and separating synthetic and semantic evaluation helps. And the advantages of algebraic specification. One significant advantage is the ability to specify complex data types clearly and conscientiously. It supports reasoning about program properties, which aids in proving correctness and identifying errors, where algebraic specifications promote reusability and modularity in software design, leading to better maintainability. And here are some of the data type of complex numbers, operations where there variables and the axioms, etc. Applications of algebraic specification. Algebraic specification is widely used in the design programming languages and type systems. It is also applicable in formal verification, ensuring that systems behave as intended. And other applications include the development of algorithms and data structures in computer science research. And the algebraic specification and abstract data type. An abstract data type is typically characterized by a set of operations that construct structured data from primitive data, extract primitive data from a data structure, modify the contents of a data structure, test properties of the data structure. Programming language providing abstract data types provide construct to represent the specification of the data type and its operations, and implement the representation of a data type and operations upon it. And examples of an algebraic specification. A simple example is a specification of a state data type, defining operations like push, pull, push, pop, and is empty. Actually, this is under like DS subject or C subject where we insert an element is called as push, and if we delete the element then it is called as pop, and if there is no element in uh, the given index then we say it is an empty. And another example is a specification of a list describing operations such as append, head, and tail. This append, head, and tail is also similar to the push, pop, and empty. These examples illustrate how algebraic specification can define both data types and their associated behaviors. And tools and languages. And we use different types of tools to perform these various, to perform in a various languages, we use the tools which will be different from each other. And various tools or languages such as OBJ and ASL are designed to support algebraic specifications. These tools provide environmental environments for specifying, testing, and verifying algebraic models. They help automate the process of reasoning about specifications, reducing manual effort and errors. Limitations of an algebraic specification. One limitation is that algebraic specification can become complex and unwieldy for large systems. They may require a steep learning curve for the unfamiliar with the formal methods and mathematical notation. Additionally, not all programming paradigms are easily represented using algebraic specification. Comparisons with other formal methods. Compared to model checking, algebraic specifications offers a more abstract approach to defining system behavior. In construct to state transition systems, it emphasizes algebraic structures rather than states and transitions. Each formal method has its strengths and weakness, making the choice depend on the specific application's context. And future direction. The integration of algebraic specification with a modern programming language in an area of active research. Advances in automated reasoning and verifying tools may enhance its practical applicability. Ongoing work aims to bridge the gap between algebraic specification and more informal software development practices. And thank you so much, sir, for giving this opportunity.